Today, we will talk about how to secure the future with our Azure Confidential Computing. Quickly go through the agenda. We will talk about the new product release and some of the new initiatives the team has been actively working on. And later on, we will talk about how we're going to secure and protect customers with confidential VM. We also have an awesome demo to show the confidential AI by working with NVIDIA and also Putopia. By the way, since we only have 30 minutes, I probably will go a little bit faster, so feel free to stop me if you have any questions. This is our Azure Confidential Computing product portfolio, which has been shared by Mark previously. The green mark actually is a new product we just announced recently. So first of all, in the left side, we have released a general availability for Intel-based confidential VM, which we introduced the NVMe accelerated for local and also remote storage by connecting with Azure Boost device. We, from the data, you can see the output from the storage has been 5x compared with previous generation, the legacy Stagazi mode, and with 16% latency reduction. And we will have accelerated networking enabled coming very soon for the Intel-based confidential VM. Meanwhile, in the last about 12 months, we are working very hard to expand Azure Confidential Computing, the regional coverage. Till today, we have covered 50+ Azure regions, including public and also US Gov, and across 140 availability zones. And meanwhile, we also established like Azure Migrate Backup, Azure Site Recovery, all these kind of features be compatible with Azure Confidential VM. Recently, we also announced the general availability of Azure Integrated HSM. Starting from Azure AMD v7 VMs, customer can be able to launch their VM attached with Azure Integrated HSM, which is hardware-baked, certified and by the FIPS 140-3 Level 3 as a key cache, which means customers, they do not need to expose their key in their VM memory in clear text if they want to achieve the performance. So that Azure Integrated HSM basically enable and protect customer keys through the whole life cycles, and also providing very high performance for the cryptographic operations. The key usage listed here, including the TLS termination, database encryption, and also signing operations. We do have the demo, which we would like to show how it works. Basically, tell customer do not need to make some of the trade-off from security versus performance. I hope that the volume should be able to go through. Let me see. Okay, wait.
Let's first take a look at the key we created in Azure Key Vault. This key is protected in the cloud by Azure Key Vault and impossible to test. Now let's use it to run 5,000 RSA sign operations. This application sends HTTP requests to AKV to perform the RSA operations remotely. As you can see, this workload completed in about 7 seconds. Next, let's run the same workload, this time using Azure Integrated HSM. This application performs secure key release to bring the key from AKV into the local Azure Integrated HSM device, and then uses it to run the RSA operations. As you can see, this workload completed significantly faster, only taking about 0.3 seconds. Today, customers often face a trade-off. Improving performance can mean moving keys into VMs in clear text, which introduces security risks. With Azure Integrated HSM, keys remain in the FIPS 143 validated boundary and get performance comparable to using the key in clear text.
Thank you. And also, one thing I want to mention is, today the Azure Integrated HSM is ready for the general purpose DA and EAV7 VMs. We were working to make sure it will work with confidential VM. Today, it is Windows released. Linux guest OS support will be coming by end of this month. Next one, we will lightly touch on the new initiatives we just talked about is the confidential live migration. Confidential VM today is not being able to live migrate it, but as a cloud provider, live migration is very critical, especially when we do the security update. We want to live migrate customers to the latest, the greatest node with security patch without impacting customer workload. And also, as a cloud vendor, cloud providers, we want to achieve the efficiency when we do the defragmentation. We also need to live migrate customers from one server to another server, but we do not want to, number one, break the confidentiality. Number two, we do not want to give the customer disruption. Here, we have been working with Intel to do actively working on the confidential VM live migration. And this is a high-level process steps that we will go through. Number one is remote attestation. The remote attestation basically to identify the scenario listed here. The customer confidential VM actually is running on unsecure node. And we have some of node has already been updated. So Azure attestation basically come in to do two things. Number one, they identify the destination of the CVM will be secure and completely patched with a higher SVN. Number two, they also will attest the migration TD in the destination node, make sure this is running 100% in the TE environment. Once the attestation is success, you can see the migration TD from the sourcing and also destination has been established the communication channel. And then the last step is the confidential VM will be moving from the unsecure node to the patched node without customer even notice. So we do have, I think Mark has demoed the live demo. For the live migration, you can see the customer blackout period is very minimal because we have limited time. So today we will not go through live migration demo, but if we have time, we definitely will happy to go back to the demo if we need. So next one is confidential AI. I think in the previous session, the G42 team comes in and talk about like for the current AI environment, actually the most useful data makes AI is now very useful in the regulated industry is actually precisely the data that we want to protect. That makes confidentiality to protect the customer data end to end, including their model and weights, is very critical. So the demo we want to show today is to see how we can leverage Azure Confidential GPU by protecting the proprietary models and also private data on Azure, Microsoft Azure with NVIDIA Confidential Computing and also Protopio stained glass transform. So the flow basically is looking like this. First of all, the SGT is a stained glass transform provided by Protopio. They basically is stochastically remap all the data, the pixels that we will show it later on, remap the data to protect the customer data before the inferencing, during the inferencing, and also post-inferencing. And also, the Protopio had their own model and weight, basically can guarantee all the remapped data can be perfectly going through the inferencing workload without performance penalty. And a confidential GPU provided by NVIDIA protect the customer model and data, model and weights. Basically, you can see the data coming from end to end will be protected perfectly, leveraging Azure Confidential GPU with NVIDIA and also the Protopio, the SGT pipeline to make sure the end-to-end data protection and privacy protection. So let me quickly go through the demo. So first of all, you can see they're waiting for the platform attestation has been successful. And then the data flow actually starts. In the left end, you can see this is a live camera shows the live picture from the street. The right side is actually from the host view through the system stochastic remapping pixel. You can see all the insensitive information is actually in the right side. There is no customer information PII data there. And then with the confidential inferencing comes in, they go through the attestation. In this demo, I'm sorry, it's a little bit small, but they go through CPU, the CVM attestation to make sure this is confidential VM. It is running on the TE environment. And also they go through the GPU attestation as well, make sure the GPU actually has turning on the confidential mode, and then achieve the end-to-end attestation, make sure that all the data has been protected in the TE environment. All right. So lastly, I think I would like to leverage this opportunity to talk about some of the security update and operational challenges on the confidential computing. So today, we have very inspirational talking about all the confidential computing, about the futures, about confidential AIs. But I also want to say operating confidential is something that we need to be aware it is some of the challenges we need to go over and overcome together jointly from all the silicon vendors and also the partners, solution partners. As we talk about, like, latest security patch is very critical to address known and some of the recently discovered the vulnerabilities. So timely patching on the confidential environment is very essential, especially to protect customer sensitive workload. But there always be circumstances that the security update need to reboot the server. So how are we going to make sure that, so first of all, we're working very hard to work with the silicon vendors to minimize the reboot requirement during the security update. But still, there are circumstances that security update will need reboot the node. How are we going to do that? How are we going to make customer minimize their impact during the process is we break down into the 3 phases. In this first phase, we will collaborate very closely. We are actually collaborating very closely with silicon partners to do all the qualification on every single security update. And then we lock down the maintenance window and give customer early notification at least 30 to 45 days prior to the actual maintenance window comes in. In the step 2, we call it controlled maintenance window, which means the customer will be in certain regions. If we do have the enough capacity, we will send notification to the customers if their VM will be impacted during the updates. And then customer will choose a maintenance window. Basically, they choose their own best time frame for themselves. They will come and call the maintenance API, try to migrate their VM from the unpatched node to the patched node. So customer has their own control during the phase 2 period. We call it control maintenance. Once the control maintenance window is over, we move to the stage number 3, which is scheduled maintenance. What does it mean is Azure actually come in and to update the nodes one by one. We call it in-place update. Basically means Azure will come in to apply the security update, reboot node, and then reboot customer VM. From customer perspective, their VM during this time period, their VM is going through the maintenance phase. The whole process will take about 30 to 45 minutes. However, customer can opt in, can choose, they can listening to some of the event. Like Azure has notification if the Azure come into this specific server, need to reboot the server to apply for the update. 15 minutes before that, customer will be able to receive the signal or receive the event, then customer can do some of the grave shutdown or backup things, but I hope the backup should happen during the phase 1 and the phase 2, but at least the customer will have the early notification 15 minutes before the server is starting to take the security update. So this is where we are. I know the process is not ideal. We are still working with all the silicon vendors to make it a better way. Impactless update, this is what we are putting the mandate to the silicon vendors and also all the partners. But still, there are some cases unavoidable security update will need reboot. This is a process we are working on. Lastly, I will hand it over to my co-presenter. This is the most common questions we got from customer. How Azure VM provisioning and boot and attestation work goes. So thanks, Ash.
So we thought we'll preemptively answer this question before we start getting into Q&A. I think the 2 most common asked questions is obviously how does updates work? and how does attestation work. Run covered the update story. There is live migration work that she previously highlighted that should take some of the burden away. But then the planned maintenance and the control maintenance windows will actually enforce some of the updates on the customers. That said, I think the customers first asked, what does attestation actually do? How does it work? Just to walk through this whole scenario, let's just say that a customer intends to actually boot a CVM. Thanks for the video there. So the CVM deployment starts, the TE gets initialized. What that basically means is we want to create something called a measured boot over here. We start measuring the components. The CPU starts initializing the memory encryption first, and then starts initializing the VTPM, and then basically starts measuring all of the components that are about to boot and starts storing them in the PCRs. With that, what it basically does is it starts creating an VM identity. The next step, once we have measured everything, is to actually make that tamper-proof. Which basically means that we're going to use the hardware root and basically attest that, sign that. And the following step, obviously, up until now, the OS has not booted. Most of the OS images that are actually created are created in clean rooms, encrypted. And we need to actually get the key to decrypt the OS disk and start the boot process, during which we usually use an attestation service at this time. In this case, in Azure, we use MAA. And we usually send in all the evidence, the TE quote, the measured quote, and once that MA actually verifies that, then the key is actually released to the system. Once the key is released, the OS actually is unlocked, and then the boot sequence continues. This is the high-level view. I'm going to actually pause. Actually, did not go through the automation here. Sorry, okay, there. I'm gonna pause. Probably this gives a very high-level view of the system. Don't want to move away from the mic. That said, I'll open this up for questions so that we can actually provide more in-depth answers to any of those questions, any of the sequence we talked about. Arun, do you want to join?
I also want to add one thing.
I think we don't have the mic, so we can't move away from the desk.
I also want to add one thing. In the Azure, every single CVM has on top of the OS disk, they have the VM GS disk, which is a VM guest state. And the VM guest state is always being encrypted and protected, which includes the customer ingest UFI and also VTPM. Either customer can choose use trusted platform, so we can have the platform platform managed key to protect customer VMGS file, or customer can choose their own customer managed key to protect their VMGS file. I think the Ash previous talk about is mainly from the customer managed key scenarios. So they can do the protection on the VTPM, eventually do the protection on the data disk encryption sealed inside of the VTPM. So if we have time, we can go through the live migration demo as well.
I honestly don't know. Do we have more questions? How much time do we have left?
9 minutes.
3 minutes?
3 minutes? Okay. We have 3 minutes.
There we go. 3 minutes. Any questions that we can answer?
Oh, here.
Oh, go ahead.
I wanted to get a bit meta about it and say, for people that want to learn about deployments in Azure, what is the best path? Specifically, I run a consulting firm that works with a lot of finance companies looking to do secure deployments. And a frequent question is, how do they embark upon the learning path?
Is your question actually related just to CVMs or in general CVM or VM deployments in Azure?
VM deployments.
Okay, so let me repeat the question. How do I embark upon a journey on deploying VMs or CVMs in Azure? What is the way to learn, or what is the documentation process? Is that the?
That's right.
Azure Learn is a very good resource. I would start with that. Has a good enough documentation and demos available there. That's the first one. I would say depending on how big the customers are, there are actually sales reps as well as assigned architects, solution architects that you can actually request for if the customer is big enough, depending on the contracts they sign. That's the second mechanism. The third one, obviously, lots of learning material available on Azure Hub through documentation. So these are probably the three resources that come to the top of mind. I can probably dig up more and send you information.
No, that's very useful.
So. Any other questions? Did not realize there was a clock here. Try to speed things up for no reason. I should have probably asked the question first. The demo? Do you want to do the live migration demo? We have about a minute.
Sure. Let me quickly go through the demo. So this is live migration demo, and on the left side, this is original, the CVM is running in this server. Right side is destination of this second server too. And you can see inside of the confidential VM, that we have hello world script is running. And now starting to do the live migration, this is the make TD. The migration TD is working, and we fast forward all the demo, and you can see it about 92% completion. And then now you can see the confidential VM has been migrated from left server 1 to right side server 2. And you can also see inside of the guest, customer blackout period is hardly to be observed. So this is of course this is demo, but actively we are working very closely to deploy into the whole Azure Confidential Computing, the VM, starting from Intel, our v6 confidential VM. All right, if no more questions, thank you for your time.